At 0030 hours on February 28th, 1943, 6 men stood in the snow 1,100 meters above the Vemork hydroelectric plant, staring down at the most heavily defended industrial facility in occupied Norway. The temperature was minus 30 degrees Celsius. The wind cut through their white camouflage suits. Below them, searchlights swept the gorge. German sentries patrolled the suspension bridge, and inside the concrete fortress, heavy water accumulated drop by drop in the high-concentration cells. They had 2 hours to descend the near-vertical ravine, cross the frozen Mana River, climb the opposite cliff face, penetrate the facility, destroy the production equipment, and escape before the German garrison of over 200 troops could respond. They carried no explosives heavier than they could run with. No backup force waited in reserve. If they failed, the British had already authorized a bombing raid that would kill every Norwegian worker in the plant and accomplish nothing. The heavy water would survive in its reinforced basement chambers. The German atomic program would continue. Joachim Ronneberg led them down into the darkness. The story begins 19 months earlier, in a laboratory at Cambridge University, where 2 German refugees were calculating the critical mass of uranium, 235. Rudolf Peierls and Otto Frisch had fled the Reich when Nazi racial laws ended their academic careers. Now, in March 1940, they were working through a problem that had troubled physicists since Hahn and Strassmann split the uranium atom in 1938. Everyone knew a chain reaction was theoretically possible. Everyone also assumed you would need tons of uranium to sustain it. Peierls and Frisch discovered you would need less than 1 kilogram. They wrote a 3-page memorandum. A bomb was not only possible but practical. A device weighing less than 5 kilograms could destroy a city. The explosive force would equal thousands of tons of dynamite. The radioactive contamination would make the area uninhabitable. Construction would require isotope separation on an industrial scale. But the physics were sound and the engineering achievable. The Frisch-Peierls memorandum reached the British government in April 1940. By July, the MAUD Committee had formed to investigate uranium weapon feasibility. By October, they had confirmed the calculations. By March 1941, they recommended immediate development. The Americans, still neutral, were briefed in October 1941. 2 months later, Japan attacked Pearl Harbor, and the Manhattan Project received unlimited priority and funding. But the Germans had a head start. They had the scientists. They had Werner Heisenberg, the man who had invented quantum mechanics. They had the facilities, the industrial capacity, and access to the only operational heavy water production plant in the world. That plant stood in Vemork, Norway, a small industrial town built into a cliff face above the Mana River, 140 kilometers west of Oslo. The site had been chosen for its geography. The Rjukan waterfall dropped 180 meters from Lake Møs to the valley floor, generating enough hydroelectric power to run the most energy-intensive industrial processes known to chemistry. Since 1934, Norsk Hydro had operated electrolysis cells that separated hydrogen from water, then separated the rare heavy isotope deuterium from common hydrogen. Heavy water molecules built from deuterium instead of common hydrogen, accumulated at a rate of 10 kilograms per day. Heavy water had commercial applications. It could trace chemical reactions. It might improve industrial processes, but its strategic value lay in nuclear physics. A uranium reactor needed a moderator to slow neutrons to speeds that could sustain a chain reaction. Graphite worked. Heavy water worked better. Heavy water absorbed fewer neutrons, required less uranium, and produced plutonium more efficiently. For a nation with limited uranium reserves and uncertain isotope separation technology, heavy water offered the most practical path to an atomic bomb. The Germans understood this. In May 1940, they invaded Norway. By June, they controlled Vemork. By August, SS officers were negotiating with Norsk Hydro management for increased heavy water production. By January 1941, the plant was producing 1,500 kilograms per year, all of it shipped to Berlin for Heisenberg's reactor experiments. British intelligence learned of the shipments in March 1941. An agent in Stockholm received a coded message from Norway describing unusual German interest in the Vemork plant. The message mentioned heavy water. It mentioned quantities sufficient for large-scale experiments. It mentioned shipments to the Kaiser Wilhelm Institute in Berlin, where Heisenberg worked. The pieces assembled slowly. Heavy water, uranium research, German physicists, industrial-scale production. By October 1941, the British War Cabinet had received a memo from the Ministry of Economic Warfare recommending the destruction of the Vemork plant. The memo cited strategic necessity. German atomic research must be delayed by any means necessary. Vemork was the only heavy water source available to the Reich. Its destruction would set their program back years. 3 methods existed. Bombing was precise but ineffective against underground facilities. Commando assault was direct but probably suicidal against a garrison that size. Sabotage was subtle but required operatives who could navigate Norwegian terrain in winter, penetrate German security, and destroy specific equipment while avoiding civilian casualties. The Special Operations Executive, formed in July 1940 to conduct sabotage and subversion throughout occupied Europe, began recruiting Norwegian volunteers. They needed men who knew the mountains, spoke the language, could survive Arctic conditions, and would follow orders to attack a target where failure meant torture and execution. They found 30 volunteers. They selected 9 for intensive training. The training lasted 6 months. Parachute qualification at Ringway, demolitions at Brickendunbury, small arms at Ariseg, fieldcraft in the Scottish Highlands, where instructors taught them to navigate by starlight, to dig snow shelters that could sustain life at -40 degrees, to identify German uniforms and weapon sounds at 500 meters. They learned to assemble explosive charges blind in under 60 seconds. They learned to kill sentries silently. They learned which parts of the human body would stop functioning if exposed to extreme cold for more than 20 minutes. 4 men would go first, as an advance party to gather intelligence and prepare a landing site for the main assault force. Operation Grouse would insert them in October 1942, giving them months to establish contact with local resistance, scout the facility, and identify the best approach routes. Operation Freshman would follow with a larger British commando force to conduct the actual attack. At 21:30 hours on October 18, 1942, a Halifax bomber released 4 parachutists over the Hardanger Plateau, 100 kilometers from Vemork. Jens Anton Paulsson, Knut Haugland, Klaus Hellberg, and Arne Kjelstrup carried radio equipment, weapons, explosives, skis, sleeping bags, food for 2 weeks, and instructions to establish contact within 5 days. They landed in a snowstorm. The containers with their radio equipment landed 3 kilometers away. They spent 6 hours searching in whiteout conditions before recovering them. By dawn on October 19th, they had skied 20 kilometers to a hunting cabin called Sandvatten, where they would establish their base. The Hardanger Plateau is the largest mountain plateau in northern Europe. 1,100 square kilometers of exposed rock, frozen lakes, and windswept snowfields above 1,200 meters elevation. The temperature from November through March rarely climbs above -20. Storms arrive without warning and can trap travelers for weeks. The Germans considered it impassable and left it unpatrolled. Grouse lived there for 4 months. They radioed London on October 20th. Position confirmed. Awaiting further instructions. They skied to Vemork and observed the facility from the heights. They noted the guard positions, the searchlight patterns, the shift changes. They drew maps. They counted German troops. They identified Norwegians working inside who might provide intelligence. They returned to Sandvatten and waited for Freshmen to arrive. Operation Freshman launched on November 19, 1942. 2 Horsa gliders carrying 34 British Commandos lifted off from Scotland, towed by Halifax bombers. The flight distance was 400 miles over the North Sea. Then, inland across occupied Norway to a frozen lake near the Grouse position. The gliders would release, land on the ice, and the Commandos would link up with Grouse for the assault on Vemork. Weather over the North Sea deteriorated rapidly. Clouds dropped to 500 meters. Ice formed on the wings. Both tow cables snapped. One glider crashed into a mountain, killing all aboard. The second crashed into another mountain. The survivors were captured by German troops, interrogated by the Gestapo, and executed under Hitler's commando order, which mandated that all captured Special Forces personnel be killed immediately without trial. Grouse heard nothing. They waited at the landing site for 3 days, then returned to Sandvatten. On November 23rd, London radioed the news. Freshmen had failed. All personnel were dead or captured. The operation was compromised. Grouse must evade German patrols and continue observing the target until further notice. The Germans increased security at Vemork. Guard strength doubled. Patrols extended into the surrounding terrain. Minefields were laid on the likely approach routes. Searchlights swept the gorge every 10 minutes throughout the night. The suspension bridge, the only vehicle access to the plant, received permanent guard posts at both ends and floodlights underneath to prevent anyone from climbing the support cables. Inside the plant, the heavy water production continued. The electrolysis cells in the basement operated continuously, splitting water molecules with 17,000 kilowatt-hours of electricity. The resulting hydrogen gas rose through separation cascades while the heavier deuterium-enriched water sank. After processing through 18 stages of enrichment, the heavy water reached 99.5% purity and collected in cylinders for shipment to Germany. Production had increased to 1,200 kilograms per month. Grouse survived the winter on reindeer meat and coded radio broadcasts. They moved between cabins, never staying more than 2 weeks in one location. They avoided all contact with Norwegian civilians to prevent compromise. They skied reconnaissance missions in -40-degree temperatures. Paulson shot reindeer with a pistol to conserve ammunition. Haugland maintained radio contact with London using a hand-crank generator that required 30 minutes of continuous cranking to charge the batteries for a 5-minute transmission. Helberg skied 70 kilometers to Ryukin to make contact with local resistance and gather intelligence on German security measures. Kjellstrup nearly died from exposure during a storm that trapped him in a snow cave for 3 days without food or sleeping bag. By January 1943, London had received enough intelligence to plan a second attempt. The British Commandos were dead. The Germans expected another airborne assault. Any conventional attack would fail against the enhanced security. But 6 men, Norwegian nationals who could pass as locals, properly trained and precisely briefed, might succeed where 34 British commandos had died. The Special Operations Executive selected 6 men from the Norwegian volunteers still in training in Scotland. Joachim Ronneberg would lead. At 23 years old, he had completed 2 clandestine insertions into Norway already, establishing resistance networks and conducting reconnaissance missions. He spoke German fluently and had memorized the floor plans of every building at Vemork. Knut Haukelid, 29, came from Rjukan. He knew the terrain, the climate, and several workers inside the plant. Kasper Edlund, 23, was a demolitions expert who had worked with industrial explosives in civilian life. Frederick Kaiser, 27, had trained as an electrical engineer and understood the technical specifications of the electrolysis equipment. Hans Storhaug, 25, and Birger Stromsheim, 24, completed the team. All 6 had completed the same training as Grouse. All 6 had volunteered knowing the freshman commandos had been executed after capture. Training intensified in January. They practiced on a full-scale mock-up of the Vemork basement, built from blueprints provided by Norwegian engineers who had worked at the plant before the occupation. They memorized the layout until they could navigate it blindfolded. They learned which pipes carried heavy water and which carried ordinary water. They learned which valves controlled which processes. They identified the 18 high-concentration cells that held the accumulated heavy water inventory and the low-concentration cells that fed them. They calculated exactly how much explosive each cell would require for complete destruction. The explosive was supplied by the SOE's technical section. Plastic explosive number 8, a mixture of RDX and mineral oil, could be molded to fit irregular surfaces and detonated with simple fuses. Each man would carry 3 kilograms, enough to destroy the target with a backup supply. The fuses were time-delayed, giving them 30 seconds to reach cover. They would use no detonator caps that might explode prematurely. The plan required precision. Enter through the cable tunnel that carried power lines into the basement. Avoid the main entrance, which was guarded. Avoid the suspension bridge, which was mined and floodlit. Descend the gorge on the plant side, where the Germans assumed no one could climb. Cross the frozen river. Climb the cliff directly beneath the plant where the slope reached 70 degrees and the searchlights couldn't angle down far enough to illuminate. Cut through the fence. Enter the basement through an external door or window. Place charges on the high-concentration cells. Ignite fuses. Exit the same way. Reach the gorge before the explosion. Climb back up and ski east toward the Swedish border. 180 kilometers away. They studied photographs taken by Grouse from the heights above the plant. They memorized patrol patterns, shift change times, searchlight sequences. They learned the Norwegian names of every piece of equipment they would encounter. They rehearsed the assault 43 times on the mock-up, reducing their time inside the basement to under 10 minutes. On February 16, 1943, 6 men parachuted from a Halifax bomber into a snowstorm over the Hardanger Plateau. The drop was precise. They landed within 500 meters of the planned position and assembled within 2 hours. They buried their parachutes, cached their container, and skied to a rendezvous point where Grouse would meet them. The rendezvous failed. Grouse had moved their base camp after a German patrol scudded past Sandvatten. For 3 days, both groups searched the plateau in deteriorating weather. Ronneberg's team broke into an abandoned cabin and waited. On February 19th, Hellberg skied past the cabin on a reconnaissance mission and noticed fresh ski tracks. By 2200 hours, all 10 men were assembled. They spent the next week preparing. The weather had been unusually warm. The snow had turned to slush in the valleys, making skiing difficult and leaving obvious tracks. They would have to wait for the temperature to drop. Haukelid and Hellberg skied to Rjukan to gather final intelligence on German security measures. They returned with news that the guard force had increased again. 30 troops now garrisoned the plant itself, with another company stationed in the town below. Ronneberg planned the assault for February 27th, but weather delayed them again. A storm moved through the plateau, bringing high winds and zero visibility. They waited in the cabin, checking equipment and rehearsing the plan. Idland inspected the explosives, ensuring the cold hadn't degraded the plastic. Kaiser reviewed the technical drawings one more time. Storhaug and Stromsheim sharpened their knives. The weather cleared on February 27th. The temperature dropped to -30. The snow hardened. At 2000 hours, they skied out from the cabin. The distance to Vemork was 40 kilometers across the plateau. Then, down through forested slopes to the gorge above the plant. They moved in single file, Ronneberg leading, each man following the tracks of the man ahead. The moon was 3/4 full, bright enough to navigate by but not bright enough to cast hard shadows that might expose them to German observers. They reached the heights above Vemork at 2300 hours. Below them, the plant was illuminated like a fortress. Searchlights swept the suspension bridge, floodlights bathed the main entrance. The gorge was dark except where the lights reached. The Mana River reflected moonlight from its frozen surface 180 meters below. Ronneberg divided the team. 4 men would enter the plant. Ronneberg himself, Kaiser, Idland, and Stromsheim. They carried the explosives and the technical knowledge to place them. Haukelid, Hellberg, Polsson, Haugland, Kjelstrup, and Storhaug would provide cover, guard the exit route, and create a diversion if the assault team was discovered. At 0030 hours on February 28th, they began descending. The slope was steeper than the photographs suggested. The snow was ice in places, requiring them to cut steps with their boots. They descended in absolute silence. Any sound would echo up to the German sentries. Any dislodged rock would alert the guards. The descent took 40 minutes. They reached the river at 0110 hours. The ice was solid, thick enough to support their weight. They crossed in pairs, placing each foot carefully to avoid the hollow booming sound that ice makes when stressed. The far bank rose at 60 degrees. Climbing took longer than descending. The cliff face offered few handholds. They climbed spread out, reducing the load on any single section of rock. Ronneberg reached the top first. He could see the fence 30 meters ahead, a simple chain-link barrier topped with 3 strands of barbed wire. Beyond it, the concrete bulk of the plant rose 7 stories. The basement entrance was on the north side, hidden from the main gates and guard posts. They cut the fence at 0145 hours. Haukelid and the covering force established positions with clear views of the main gate and suspension bridge. If Germans approached, they would open fire, giving the assault team time to complete the demolition and escape. They carried Sten guns with 3 magazines each and orders to avoid engagement if possible. Ronneberg, Kaiser, Idland, and Stromsheim moved toward the basement entrance. They walked upright, calmly, as if they belonged there. Running would attract attention. Crouching would look suspicious. They wore white camouflage over their uniforms and carried their weapons slung. If challenged, they would respond in German and claim to be inspectors from Berlin. This would buy seconds, long enough to use the weapons. The basement entrance was a steel door at ground level, facing away from the guard posts. It should have been locked. Ronneberg tried the handle. Locked. They moved along the wall to a window. The window was 1 meter above ground level. reinforced with steel bars, and covered from inside with blackout curtains. Kaiser tested the bars. They were secured with bolts that had rusted. He pulled. The bars came free. The window opened. No alarm sounded. They could hear machinery inside. The hum of electrical systems and water pumps. Kaiser went through first, dropping to the floor inside. Eidland followed with the explosives. Stromsheim went next. Ronneberg came last, pulling the window closed behind him. They were in a corridor lined with pipes. The high-concentration cells were 20 meters ahead. Through 2 doors, the lights were on. They could hear someone moving in another room. Footsteps and the sound of tools. A Norwegian worker or a German guard. They moved forward. The first door opened into a control room. Empty. Gauges lined the walls, monitoring pressure, temperature, flow rates through the electrolysis cascade. The second door led to the cell room. 18 cylindrical cells stood in 3 rows, each cell 2 meters tall and half a meter in diameter, constructed from stainless steel. Pipes connected them in series, carrying the progressively enriched heavy water through each stage of concentration. At the far end of the room, 9 smaller cylinders held the final product, ready for shipment. The accumulated heavy water inventory of the entire plant, 9 months of production, was contained in this one room. Ronneberg checked his watch. 12 hours. They had been inside for 20 minutes. The plan allowed 30 minutes total before the guard shift changed and increased patrols made escape difficult. Eidland began placing charges. He molded the plastic explosive against the base of each high-concentration cell. Where the steel was thinnest, the explosive was cold and stiff, difficult to shape, but his hands had memorized the motion during 43 rehearsals. Kaiser placed charges on the cylinders holding the final product. Stromsheim covered the door, listening for approaching footsteps. A door opened. Footsteps approached. A Norwegian worker in overalls appeared in the doorway. He saw 4 men in white camouflage placing explosives on the cells. He froze. Ronneberg stepped forward and spoke in Norwegian. "We are British soldiers. We are here to destroy the heavy water. Leave immediately and tell no one. You have 2 minutes." The worker nodded and left. They heard his footsteps running down the corridor. Eidland finished placing the charges. 9 cells, each with 300 grams of explosive. The cylinders received smaller charges, enough to rupture them, but not demolish the building. They wanted to destroy the heavy water in the production equipment, not kill Norwegian workers sleeping in the barracks above. Kaiser attached fuses. They were simple friction devices, activated by pulling a wire. Each fuse had a 30-second delay. Ronneberg checked the placement one final time. Every charge was positioned correctly. Every fuse was attached. They had rehearsed this 43 times, and it had gone exactly as planned except for the Norwegian worker. At 02:15 hours, Kaiser pulled the fuse igniters. They heard the fuses hiss. 30 seconds. They ran down the corridor, through the control room, to the window. Out. Ronneberg was last. He pulled the window closed behind him. They ran toward the fence. 20 seconds. They reached the fence line. 15 seconds. They ran through the gap they had cut earlier. 10 seconds. The explosion was muffled, contained within the concrete basement. A dull thump. Then, the sound of breaking steel and rushing water. Then silence. No alarm sounded. No searchlights swung toward them. The German guards at the main gate hadn't heard. The sentries on the suspension bridge continued their patrol. The explosion had been too quiet. The walls too thick. They reached the cliff edge. Haukelid was already descending. Helberg followed. Paulson waited at the top, covering their retreat. They descended as fast as they dared, half climbing, half sliding. The cliff face was ice. Handholds broke away. They fell the last 5 meters to the riverbank. Behind them, lights came on in the plant. Someone had discovered the damage. An alarm began to sound. A mechanical siren that echoed through the gorge. Searchlights came alive, sweeping the slopes. The river, the opposite cliff. They were across the river by then, climbing the far slope. The searchlights couldn't reach them. They were in shadow. They reached the top at 02:45 hours and stopped to look back. The plant was fully lit now. Troops poured from the barracks. Vehicles moved toward the suspension bridge. The alarm continued. But the bridge was intact. The building was intact. The Norwegian workers were alive. The only damage was in the basement, where 9 months of heavy water production had drained into the Mana River and 9 high-concentration cells were twisted steel wreckage. They skied east, toward Sweden. The distance was 180 kilometers across mountains where German patrols would be searching within hours. They separated into two groups to reduce the chance of total capture. Ronneberg, Kaiser, Eidland, and Stromsheim skied toward Sweden. Haukelid, Hellberg, Polsund, Haugland, and Kjellstrup skied toward the plateau to continue resistance operations in Norway. The ski to Sweden took 16 days. They traveled only at night, hiding during daylight in snow caves or abandoned cabins. German patrols searched the mountains, but the searchers stayed on marked trails and avoided the high country where the cold could kill in hours. The fugitives traveled where no one else would go, across frozen lakes and wind-scoured ridges, through terrain that offered no shelter and no food. They reached Sweden on March 15, 1943, suffering from frostbite and malnutrition but alive. Haukelid's group evaded capture for 2 months, then made contact with other resistance cells operating in the region. They continued sabotage operations throughout 1943 and 1944, derailing trains, destroying communication lines, gathering intelligence. 3 of them survived the war. Paulsson and Haugland reached Sweden in October 1943. Hellberg was captured in March 1944, escaped, and skied to Sweden. Kjellstrup fought with the resistance until the German surrender in May 1945. Inside the Vemork plant, Norwegian workers surveyed the damage at dawn on February 28. The high-concentration cells were destroyed beyond repair. The accumulated heavy water inventory was gone, drained away. The low-concentration cells were intact, but rebuilding the cascade would require months and specialized equipment that Germany could no longer spare. Production resumed at reduced capacity in April 1943, producing half the previous output. German authorities investigated, but found no leads. The saboteurs had left no evidence. The Norwegian worker who had seen them refused to cooperate with Gestapo interrogators. Local resistance members provided false information that sent German troops searching in the wrong direction. Within a week, the Germans concluded that local partisans were responsible, not British commandos. This saved Norwegian civilian lives. Hitler's reprisal doctrine mandated that for every German killed by partisans, 10 Norwegian civilians would be executed. Since no Germans had died, no reprisals occurred. The British learned of the success on March 2nd, when Ronneberg radioed from inside Sweden. The BBC broadcast a coded message confirming the operation. The Gunnerside team has completed its assignment successfully. Winston Churchill received the news in a brief memo. He wrote in the margin, "What is heavy water?" An aide explained. Churchill wrote a second note. "This is excellent. Inform the Americans." In Berlin, Albert Speer received reports of the sabotage on March 5th. He ordered an assessment of German heavy water requirements for atomic research. The report concluded that Vemork could be rebuilt, but that security costs would be prohibitive. Alternative heavy water sources existed but were located in Germany proper, where Allied bombing had already destroyed several chemical plants. The report recommended continuing research without heavy water, using graphite moderation instead. Heisenberg received the news in April. His reactor experiments at the Kaiser Wilhelm Institute had consumed most of the heavy water inventory from Vemork. The new shipments had been scheduled for May. Without them, his research would stall. He requested additional funding to construct a graphite-moderated reactor. The request was denied. Resources were needed elsewhere. By June 1943, the German atomic program had effectively ended as a weapons project, continuing only as basic research with minimal funding and no military priority. The Allied intelligence community learned these details slowly, piecing together information from intercepted communications, prisoner interrogations, and resistance reports. By August 1943, British and American analysts had concluded that the Vemork sabotage had achieved its strategic objective. German atomic research would not produce a weapon before the war ended. The Manhattan Project could proceed without fear that Germany would develop a bomb first. But Vemork continued producing heavy water at reduced capacity. By November 1943, production had reached 40% of pre-sabotage levels. The accumulated inventory approached 500 kilograms. This was enough to renew German research if transported to Germany safely. The Allies faced a decision: accept the risk that Germany might restart their atomic program, or destroy the plant completely. Bombing was reconsidered. The United States Army Air Force had developed new precision bombing techniques. The Norden bomb site could place bombs within 200 meters of a target from 6,000 meters altitude in clear weather. A raid on Vemork would require careful planning, but was feasible. On November 16, 1943, 140 B-17 Flying Fortress bombers struck Vemork and the surrounding industrial facilities. They dropped 700 tons of high-explosive bombs from 6,000 meters altitude. The raid destroyed several buildings, killed 22 Norwegian civilians, and damaged the power station. The heavy water facility in the basement survived intact. The concrete walls were too thick. The bombs that hit the plant detonated on the upper floors and roof, causing superficial damage but leaving the electrolysis cells operational. Production continued. By January 1944, another batch of heavy water was ready for shipment. The Germans decided to evacuate the entire inventory to Germany, where it could support research at facilities beyond Allied bombing range. They would transport the heavy water by rail to Rjukan, then by ferry across Lake Tinnsjø, then by rail again to the port at Menstad, and finally by ship to Hamburg. Norwegian resistance learned of the plan in early February. A railway clerk in Rjukan noticed German soldiers guarding a shipment of industrial cylinders marked for priority transport. He reported this to his contact in the local resistance cell. The information reached London within 48 hours. The Special Operations Executive authorized immediate action to prevent the shipment from reaching Germany. Knut Haukelid received the assignment. He was the only Gunnerside operative still in Norway, still conducting resistance operations in the Rjukan area. The task was simple: prevent the heavy water from reaching Germany. The method was left to his discretion. He considered several options: ambush the train, too many German guards, attack the truck convoy between the plant and the railway station, too visible, too many civilian witnesses, sabotage the railway line. The Germans would repair it quickly and delay the shipment by hours. Sink the ferry. The ferry was called the Hydro, a double-ended railway car ferry that crossed Lake Tinnsjø daily, carrying passengers and rail cars from Mael on the western shore to Tinnoset on the eastern shore. The crossing took 40 minutes. The lake was 450 meters deep. If the ferry sank in deep water, the heavy water would be unrecoverable. Haukelid recruited 2 men from the local resistance: Rolf Sorli, an engineer who worked on the ferry, and Knut Lear Haugen, who had participated in earlier sabotage operations. They would plant explosives on the ferry, timed to detonate when the vessel reached the deepest part of the lake. The explosion would sink the ferry quickly, preventing passengers from escaping but ensuring the heavy water was destroyed. They discussed the civilian casualties. The ferry carried passengers on every crossing. Norwegian civilians, possibly children. Killing them would constitute murder, not military action. Haukelid consulted with London by coded radio. The response was unequivocal: the heavy water must not reach Germany. Civilian casualties were regrettable but acceptable compared to the risk of a German atomic bomb. On the night of February 19, 1944, Haukelid, Sorli, and Lear Haugen boarded the ferry at Mael. The vessel was tied up for the night, unguarded except for a single Norwegian watchman. Sorli led them below decks to the crew quarters. Beneath the floorboards, they accessed the bilge where the hull curved inward. They placed 9 kilograms of plastic explosive against the hull plates at the bow, below the waterline. The charge was positioned to blow a hole approximately 1 meter in diameter, flooding the forward compartment rapidly. The timer was a simple alarm clock mechanism connected to a detonator. They set it for 11 hours. The ferry would depart Mael at 1,000 hours. The deepest part of the lake, where the bottom dropped to 450 meters, lay 30 minutes into the crossing. The explosion would occur at 10:45 hours, when the ferry was 10 kilometers from either shore. They left the explosives and departed the ferry at 200 hours on February 20th. The watchman noticed nothing. At 1,000 hours, the ferry departed on schedule with 53 people aboard, 29 Norwegian passengers, 9 German soldiers guarding the heavy water shipment, and 15 crew members. The heavy water was loaded in 39 drums in a rail car on the main deck. At 10:45 hours, the alarm clock completed its cycle. The detonator fired. 9 kilograms of plastic explosive detonated against the hull plates, blowing a hole 1.2 meters in diameter below the waterline. Water rushed in at tons per second. The bow sank within 4 minutes. The ferry tilted forward, sliding the rail car toward the submerging bow. Passengers scrambled toward the stern. The ferry was sinking too fast. The stern rose at 45 degrees. People fell or jumped into the lake. The water temperature was 4 degrees Celsius. The ferry sank completely 7 minutes after the explosion. 27 people died. 14 passengers drowned in the lake or died from hypothermia before rescue boats arrived. The 9 German guards went down with the rail car. 4 crew members died trying to launch lifeboats. 26 survivors were pulled from the water suffering from severe hypothermia. The rail car with the heavy water sank in 400 meters of water. The drums ruptured from pressure during descent. The heavy water mixed with ordinary water and dispersed. German authorities sent divers to the site in March 1944. They confirmed the railcar's position but declared recovery impossible. The heavy water was lost. German atomic research continued without heavy water through 1944. Heisenberg's team constructed a small experimental reactor using graphite moderation. It never achieved criticality. By February 1945, Allied forces had overrun most German research facilities. The Kaiser Wilhelm Institute was captured by Soviet troops in April. American intelligence teams found Heisenberg's reactor buried in a cave in Haigerloch, southern Germany. It contained 1.5 tons of uranium metal and 2 tons of uranium oxide. It had never produced a sustained chain reaction. Post-war interrogations revealed that German atomic research never developed weapons potential. Heisenberg and his colleagues had pursued reactor physics, not bomb design. They lacked the industrial resources to produce fissile material. They lacked the calculations that Peierls and Frisch had developed, showing that a bomb was possible with less than 1 kilogram of uranium, 235. The heavy water program at Weimork had supported basic research, not weapons development. This was not known in 1943. British and American intelligence analysts believed Germany might produce a bomb. The belief was rational given Germany's scientific capability and industrial capacity. The Weimork sabotage was justified by the intelligence available at the time. The sinking of the ferry was justified by the same reasoning. Whether these actions were necessary in retrospect is a different question from whether they were justified when ordered. The men who conducted Operation Gunnerside lived with the knowledge that they had killed to prevent a weapon that was never built. Ronneberg returned to Norway after the war and refused to discuss the operation publicly for 40 years. When asked about it in interviews during the 1980s, he emphasized that they had followed orders and completed their mission without killing anyone directly. The ferry was different, he said. The ferry was Haukelid's decision. He did not judge it. Haukelid wrote a memoir in 1954 titled Skis Against the Atom. He described the decision to sink the ferry as the most difficult he ever made. He knew civilians would die. He knew some would be children. He believed the risk of a German atomic